So yes, this is the second class of the redox reaction. Okay, in the last class, I just told you the definitions of oxidation and the definition of reduction. Basically, oxidation can be defined as in four ways, and also reduction can be defined as in four ways, basically, right? So, and also I told you the definition of redox reaction. Basically, it's a reaction in which oxidation and reduction can take place simultaneously, basically. In a reaction, when there is an oxidation, so obviously there would be a reduction. There would be a reduction, basically. If someone is going to lose electron, obviously there would be someone which would be gaining electron. So this is mandatory. This is mandatory in any chemical reaction. In any chemical reaction, there is oxidation and there is a reduction, basically. So oxidation is the loss of electron, it's addition of oxygen, it's the loss of hydrogen, is increase in charge. And if you talk about like reduction, so it can be gain of electron, removal of oxygen, the gain of hydrogen, or you can say the decrease in charge. So, okay, but before going to discuss in the detail, you must know how to find out the oxidation numbers, because when I would be giving you any type of equation to find like whether the oxidation is going to take place, or you can say the reduction is going to take place. So it depends. Sometimes you can consider the number of hydrogen atoms, sometimes you consider the number of oxygen atoms, sometimes you consider the charge, okay, and sometimes you consider like it's a gain of electron or a loss of electron. So basically, before going into detail, I would like to tell you like what is basically the oxidation number. Oxidation number. Oxidation number, basically. Oxidation number versus valency. Oxidation number versus the valency, right? So, valency is the combining capacity of an element. Valency is the combining capacity of an element. Okay? Valency is the combining capacity of an element. Let's suppose, as you can see, the periodic table, carbon is in group 4. So carbon has a valency that is equal to 4. So carbon can make 4 bonds with other elements. Carbon can make 4 bonds with other elements. But on the other hand, if you talk about like the oxidation number, basically this is the charge. Basically, this is the charge, which is variable. Okay, the valency is fixed. Okay, the valency is fixed, but the charge is variable. But the charge is variable. Okay, the valency cannot be negative. The valency cannot be negative. Remember, because it's the combining capacity. Oxygen has a valency that is equal to 2. Oxygen can make 2 bonds. Oxygen can make 2 bonds. As you can see the structure of water, as you can see the structure for water, this is the structure for water. So oxygen has made first bond with this hydrogen and the second bond with this hydrogen. So obviously oxygen is going to have the 2 bonds with other hydrogens. So why? Because the valency of oxygen is 2, means that I can say that the combining capacity of oxygen is 2. So that's why it's going to combine with the 2 other atoms. In this case, that is hydrogen. So, but the charge is variable. As if you remember in IGCSE or O levels, you used to discuss in the periodic table transition metals. So what was the properties of transition metals? We used to tell you like a high melting point, high boiling point, high density, they form colored compounds, they have a variable charge, they have a variable oxidation number, they can be used as a catalyst, so basically this is the thing that you used to discuss. So this is the same for oxidation number. This is variable, and remember, this can be negative, this can be negative, it can be 0, can be positive, can be negative, and can be 0. Remember, can be 0, okay? And also this is the variable. This is variable, okay? So, so how can I find out the oxidation number of each element if the examiner has given me, like you can say in a compound, okay? Let's suppose sometime he gives you KMnO4. So you would be finding out the charge of manganese in KMnO4. You would be finding out the charge of manganese in KMnO4, okay? So there are some rules. There are some rules to calculate the oxidation numbers. There are some rules to calculate the oxidation numbers, remember, okay? So the first one is, let me write down rules to calculate oxidation number. Rules to calculate oxidation number. Number one, oxidation number of a single element. Oxidation number of a single element is 0. I would be telling you, just wait. I would be telling you each and everything. Okay. Oxidation number of hydrogen is +1. Okay. Oxidation number of oxygen is -2. Okay. Oxidation number of group 1 elements. Is +1. Oxidation number of group 2 elements is +2. Okay, these are the rules that we would be considering when we would be going to like calculate the oxidation number of a particular element that is like mentioned by the examiner. Okay, right? So let's suppose this is KMnO4, and in this you have to calculate the charge of manganese. As you all know that potassium is in group 1, as you all know that potassium is in group 1, it should be +1. So we have 1 potassium, 1 Mn, and 4 oxygens is equal to 0. Potassium is +1, Mn is unknown that we have to find out. 4, oxygen is -2 is equal to 0. So this is +1. This is Mn. Plus minus minus 4 into 2 is 8 is equal to 0. So then Mn, okay, this is +1 and this is -8. Okay, this would be +-7 is equal to 0. So I have to find out the manganese, that is your subject. So you are supposed to shift -7 to the right hand side of the equal, like you can say opposite direction. So this would be +7. So this is the charge on manganese in the following compound, that is potassium manganate, that is KMnO4. So in this way, we would be finding out the charge of a particular element in the following compound. Let's suppose this is K2Cr2O7. In this, we are going to find out the charge of chromium. So I can say that this is 2K plus 2Cr plus 7 oxygen is equal to 0. K is +1. Okay. then 2Cr, then 7 oxygen. Oxygen is -2 is equal to 0. Then 2 ones are 2, then 2Cr plus minus minus 7 into 2 is 14 is equal to 0. Then this is 2Cr plus minus minus 2 minus 14 is -12 is equal to 0. Then this is 2Cr, then this is plus 12. Then I have to find out the Cr. I need to divide the two. So just like that, then I would be getting +6. So this is the charge of chromium in this compound. So basically what you need to know, the other charges, like the charge of potassium and the charge of oxygen, basically, okay? Are you getting my point? Yes?
Yes.
Any
Yes.
confusion? Okay. Okay. Can you tell me the charge of sulfur in H2SO4? Can you tell me the charge of sulfur in H2SO4? Fast, 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 fast.
+6, I think.
Okay. Okay, okay. Like most of you are saying that this is +6. Okay, let me check this. So this is 2H, 1 sulfur, and 4 oxygens is equal to 0. 2H. H is +1. I told you in the rules that H is +1, remember? So that's why we just like write down these rules and then we have to follow. Then sulfur is unknown. We have to find out. Then 4 oxygen atoms, each oxygen is -2 is equal to 0. This is 2, this is sulfur, plus minus minus 4 into 2 is 8 is equal to 0. Then 2 minus 8 is -6 is equal to 0. So sulfur is equal to +6. So this is +6. Remember, this is +6. Okay. Okay. Then H2O2, hydrogen peroxide. Can you tell me the charge of oxygen in H2O2? Yes, fast. Jaldi se. The charge of oxygen in hydrogen peroxide, yes.
1.
So +1, -1.
+1 or -1?
-1.
Plus.
Plus, okay. Roha is saying this
Yeah,
is
it's
-1. Okay, let me check this. Some are saying +1, some are saying -1. Okay. 2 hydrogens, 2 oxygens is equal to 0. Hydrogen is +1. 2 oxygens, that is to be find out, like this is unknown, this is your subject, this is equal to 0. So 2 ones are 2, then 2 oxygens is equal to 0. Then I need to find out the oxygen, so I need to shift +2 over there. That would be -2. Oxygen is the subject, so I need to divide this 2 over here. So this should give me -1. So yes, this is -1. This is not +1. This is -1. Okay, this is -1, right? Okay. ClO2K, and then this is, yes, fast, fast, fast. Roha is saying this is +3. Yes. Anyone can
Yes, it is.
confirm? Okay, this is +3. Sayyid Muhammad Ahmad, what do you think, man? Is this +3 or not? And Soha, Maria, Samir, Kamran, Hadia, Muzaffar, Hafsa, Irtaza. Can you confirm?
Yes, it is.
Okay. 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 K is plus 1. Cl we have to find out. 2 oxygens, each oxygen is minus 2, is equal to 0. So this is plus 1. This is chlorine. Is equal to 0. So chlorine minus 4 and plus 1 is going to give me minus 3. I need to find out chlorine. I should just this is plus 3, right? Easy, 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 easy. Okay, 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 okay. P2O5, phosphorus. Yes, phosphorus.
Sir, 5 plus 5.
Plus 5. Plus 5. Okay. 2P, 5 oxygens is equal to 0. P we have to find out. Each oxygen is minus 2 is equal to 0. This is 2P. This is 10 is equal to 0. That should be plus ka 10. And then P is equal to plus ka 10 upon 2. That would give me plus 5. So good. P is plus 5. Okay. P is plus. Okay. These are the compounds having no charge. These are the compounds having no charge. But the question is why they have no charge. Why they have no charge. Let's suppose I'm asking the overall charge, the overall charge of H2O is 0. The overall charge of H2O is 0. But why? But why? Because H is plus 1. I told you H is plus 1. And then I told you oxygen is minus 2. So this is H2O. This is H2O. As you can see, this is 2 and hydrogen is plus 1. And you have minus 2 is equal to 0. Obviously, if you are going to calculate these numbers, so you would be like looking at your calculator. So the answer is 0. So this is the reason there is no charge on water. There is no charge on water. And what if I'm going to give you ammonia? What if I'm going to give you ammonia? As you know that, let's suppose I'm asking, can you tell me the charge of nitrogen in ammonia? Yes. Can you tell me this? The charge of nitrogen is ammonia. Yes.
-3. -3.
So N is the subject, H is plus 1. So 3H is equal to 0. So this is plus 3 is equal to 0. N is equal to minus ka 3. N is equal to minus ka 3. So this is the charge of nitrogen in ammonia. Now I'm asking that why ammonia has no charge, why this is 0, why there is no charge on ammonia. You are supposed to say because we have one nitrogen, that is minus 3. We have 3 hydrogens, each hydrogen is plus 1. So 3 hydrogens would be plus 3. So if you are going to calculate this, you would be getting 0. This is the reason ammonia has no charge. This is the reason ammonia has no charge. But if I ask, have you listened in like you can say in chemical bonding, I told you in dative covalent bond that ammonium ion, ammonium is NH4. Ammonium is NH4. Can you tell me what is the charge on ammonium? Yes. Can you tell me what is the charge on ammonium? Yes.
+1.
Why this is plus 1?
Because it can one
Why this
hydrogen
is?
atom. Sir, because of hydrogen atom.
Okay, you told me in the previous question that nitrogen is minus 3. You told me in the previous question that nitrogen is -3. So I'm going to put this in this question. So nitrogen is -3, each hydrogen is +1. I have 4 hydrogens. I have 4 hydrogens. So I'm going to put +4 over here. So I would be getting the overall charge, that is +1. So this is the reason I can say that ammonium is having +1 charge. Are you getting my point? Yes, Samir, Kamran, Shamir, yes, Soha, Tala, Hafsa, Irtaza, yes. Are you all
Yeah.
getting my point?
Yes, sir.
Okay.
Yes.
Can you tell me what is the charge on hydronium? Can you tell me what is the charge on hydronium? Hydronium ion. And you know the formula for hydronium ion is H3O. H3O. Yes. What is the charge on hydronium ion? Yes. Easy, easy, easy. Same thing,
One.
same. +1 or -1?
+1.
+1. Hafsa is saying
+1.
this is +1. Okay. 3 hydro. Each oxygen is -2. So 3 hydrogens. Each hydrogen is +1. I have 3 hydrogens. That would be +3. So the overall charge is +1. This is the reason I'm going to have a positive charge on hydronium ion. So remember, these are the reasons that we always see the charge. If there is a positive charge, if there is a negative charge, so it means that there is something else due to which there is an overall charge. But rest of the compound, if you can see, this is ammonia, and this is P2O5, this is water, this is H2O2, KC, all have no charge, all are neutral. Why? Because when you are going to put the charges in that compound, so basically the overall charges are going to be cancelled by each other. So as a result, it's going to give you the 0. So that's why there is no charge on these compounds. Okay. But what if I'm going to give you the ions? I'm going to give you the ions. Let's suppose I'm going to give you S2O7, S2O7 2 minus. Can you tell me the charge on sulfur? Yes, can you tell me the charge on sulfur?
Sir, +7.
Oh, +7. I think so. No, I think so. No. Yes, for sure. This is Roha is saying this is +6.
Yeah, it
Irtaza,
is.
Irtaza, yes, Irtaza.
I think it's -2.
Oh, -2. Okay.
I got +6.
Oh, okay. Tala, can you tell me? Tala, can you tell me what is this? Is this -2 or +6 or +7? Yes. It's very simple.
+7.
+7. Okay. Let me check this. Let me check this. Let me check this. 2s, 7 oxygens. Each oxygen is -2. Now I'm not going to have, I'm not going to write down is equal to 0. I'm not going to write down equals to 0. Why? Because now there is a charge. In those examples, in which I was writing down 0 0 0 0 0, oh sorry 0 0 0 0 0. But why? Because there was no charge. 0, there is no charge, there is no charge, there is no charge, there is no charge. But right now there is a charge, that is -2. So you are supposed to write down -2 over here. Now you can calculate, simple. 2s, each oxygen is -2, is equal to -2. So this is 2s plus minus into 14 is equal to -2. So this is 2s, this is -2. So I am shifting this -14 over there. It would be +14. That would be giving you the +12. So then 2s, I need to find out s. So what I'm supposed to do, basically, I'm supposed to divide this 2, and then I would be getting +6. Yes. Are you all getting my point?
Yes, sir.
This is very easy,
Yes.
man. This is very easy question. This is very easy topic. This is baby topic, and this is second time you are going to learn, right? Okay. Okay. Can you tell me this? Yes. The charge on Mn in MnO4 minus in MnO4 minus. Yes. Sorry.
+7.
+7. Roha is saying this is +7. Okay.
7.
7. Okay. Tala, can you tell me? Can you confirm, please? Is this +7 or not? Sayyid Mohammed Ahmed, +7. Okay. Sayyid Mohammed Ahmed.
Yeah, +7.
Okay. Let me check this. This is Mn, 4 oxygens. Each oxygen is -2 is equal to -1. This is plus minus minus 4 into 2 is 8 is equal to -1. This is -1 plus 8. That would give you great. Great. Now you are on the track. Now you are on the track. Okay. I need to ask individually. Wait. Okay. Yes. Can you tell me, like I'm talking to Soha, can you tell me the charge on sulfur in sulfate? Sulfur. Yes. Yes. And also I'm asking to Tala. Yes, Tala.
6.
Sulfur, the charge on sulfur. Okay, you are saying this is 6. Plus 6. S plus 4 oxygens. So each oxygen is -2 is equal to -2. So this is sulfur plus minus minus 4 into 2 is 8 is equal to -2. So -2 plus 8, that is +6. So sulfur is +6. Exactly. Yes. So those who are saying that this is +6, they were right. Yes. Okay. This is easy. Okay. This is easy. And okay. So moving on to the positive ions, just like that, I have NH4 plus. This is a cation, right? Can you tell me the charge on nitrogen? But fast. We need to balance equation. We need to learn balancing equation. Then in balancing, like after learning the balancing equation, then I would be telling you how can you identify where is oxidation is going to take place and where the reduction is going to take place and what is an oxidizing agent and what is the reducing agent. Okay, Roha is saying that this is -3. Can you confirm, please, Hadia, Muzaffar, and also the Maria? Yes, can you confirm?
-3.
Is this -3? Okay.
Yes.
Okay, -3. Sayyid Muhammad Ahmad, no. Sayyid Muhammad Ahmad, no. A big no. This is not +1. So see this. Nitrogen is the subject. 4 hydrogens. Yes, Maria, you're right. This is +3. -3. You need to write down, mention the charge as well, right? So each hydrogen is +1. It should be +1 because the overall charge is +1. Okay, this is plus. Obviously, it means that this is +1, right? So whenever you will see only positive charge, so it means that this is +1. Nitrogen, then this is +4 is equal to +1. Then nitrogen is equal to 1 minus 4. That is equal to -3. Yes, Samir, this is good. This is -3. Okay. Yes. Anyone having any confusion in these charges? So do let me know. Otherwise, they would not be able to learn how to balance a redox equation. Yes, I'm asking to all of you individually. Yes. Do you have any confusion? Yes or no? I need 13 answers.
No.
Okay, like -2. Like I need 11 answers. Okay, Maria, no questions. Maria, good. Yes, Tala, Hadia
I don't have
Muzaffar,
No.
Hadia Muzaffar. Okay, and then Roha, Irtaza, Samir Kamran, Shamir, and also Soha and Zoha. Yes, any question? Yes. Ultimately, I would be telling you if you are saying that I am having any confusion. Yes, for sure, I would be telling you. Yes, no, sir. Okay, Zoha. Then Soha, how are you? Soha, yes. Any confusion? Samir Kamran, you are not replying. Shamir, okay. Yes, Samir, are you here? Okay, Samir, no, good. Okay, okay. But again, I'm saying if you are having any question, so do let me know after the class, okay? And also, I have recorded a session previously on like redox, like oxidation numbers. You can see, like, or you can also see that. Okay. Okay. Then I'm going to have a balancing equation. This is a redox. This is a redox equation in which you will see oxidation and reduction. Right. There is not. This is not a general, a normal equation in which like just balance elements like that, but in this equation we are going to balance the charge as well. Okay, like we have to balance electron as well basically. So here are some rules, to balance redox equation. So you are supposed to write it down, okay? So rule number 1. Okay, number 1, is split equation into two halves. Then balance metals, then balance non-metals, other than hydrogen and oxygen, okay, other than hydrogen and oxygen, then balance oxygen by H2O, balance hydrogen by H positive ions, balance the charge by adding electrons, add two half equations, after cancelling electrons. after cancelling electrons. Let me explain something. Wait. Let's suppose I'm going to give you an equation just like that. I need your concentration. Okay. So, split this equation into two halves. Split this equation into two halves, basically. I'm sharing my screen, no worries. Split this equation into two halves, okay? So I'm going to split this equation into two halves, like I mean to say that in oxidation and reduction. Let me explain this. So MnO4 minus is changing into Mn2 plus. Can anyone tell me, is this oxidation taking place or reduction? Can anyone tell me? That's so much easy. Yes. Can anyone tell me reduction is going to take place or oxidation? Yes.
Sir, oxidation.
Oh, reduction. Someone saying oxidation. Let me check this. Can you tell me the charge of manganese in MnO4 minus? Can you tell me the charge of manganese in MnO4 minus? Yes.
+7.
+7. It's changing to +2. So +7 to +2. What I told you. Just look at this. What I told you. +7 to +2 means that increase in decrease in charge. +7 to +2, +7 to +2, +7 to +2, decrease in charge. This is decrease in charge. So this is reduction. Am I right? Are you getting my point? Am I right? Yes or no?
Yes.
Yes or no? Good. And then I'm changing. This is the +2. This is +3. Obviously, without any checking, this should be oxidation equation. Okay, easy. So far, this is easy. If I'm not wrong. So far, this is very easy. And then, okay, I'm going to balance the metals. Okay, in the first equation, I'm going to balance the metals in the first equation. Okay, just like that. Okay. Mn is a metal. Manganese is a metal. So in the left hand side, you have one manganese. In the product side, you have one manganese. So the manganese metal is already balanced. No need to touch this manganese. Okay, this would remain the same. Now, move on to the next rule, that is non-metals other than hydrogen and oxygen. There is no any non-metal. Other than hydrogen and oxygen. There is no any non-metal. Okay, I'm skipping this rule. Okay, so balance oxygen by H2O. I would ask, beta, how many oxygen atoms in the left hand side? You will say, sir, 4 oxygen atoms. I will say, just write 4H2O over here. 4H2O over here, because I told you you are supposed to balance oxygen by H2O. Let's suppose in the reactant side you had 7 oxygen atoms. I would be writing 7H2O in the product side, because this is the rule. Always you are supposed to balance oxygen by H2O. Remember, always you are supposed to balance oxygen by H2O. So after writing H2O, how many hydrogen atoms I have? So you will say, sir, 8. I would ask why. You will say, sir, here is 4. So 4 into 2 is 8. I would say, okay, great. So it means that I have 8 hydrogens in the product side. In the product side, I have 8 hydrogen atoms. What I'm supposed to do, I would be considering this rule. I would be considering this rule. This rule says balance hydrogen by H positive ions. Okay, then what I'm supposed to do, I'm going to write 8H positive ions. 8H positive ion. Now hydrogen is balanced. Now hydrogen is balanced. Oxygen is balanced. Metals are balanced. Now what I'm supposed to do, balance the charge. Balance the charge by adding electrons. Balance the charge by adding electrons. Okay. Now it's quite tricky. I need your concentration. Now it's quite tricky. I need your concentration, man. Okay. So, okay. Hadia Muzaffar, can you tell me what is the charge on the product overall? I'm asking the overall charge on the product side. Yes, Hadia, can you tell me this?
+3.
Plus, can anyone tell me? Yes, Hafsa, Muhammad Ahmad, Irtaza, Maria, Roha, Samir, Shamir, Soha, Tala, Zoha. Can anyone tell me, yes, what is the charge on the overall product side? Yes.
+2.
+2. Maria is saying this is +2. Yes, Tala, can you tell me? Can you confirm, please? Is this +2 or not? Or something else? Yes, fast.
I think +2 as well.
Okay. Zoha, can you tell me? Can you please confirm? Roha, can you please confirm? Irtaza, can you please confirm? Samir is saying this is +2. Okay. Yes.
I think it's +2.
Okay. Okay. Oh, most of you are saying that this is +2. Yes, you are right. You are 100% right. This is +2. There is no charge on water. There is no charge on water. What I told you in this chart. If there is no charge, means that this is 0. There is no charge on water. There is no charge on water. So overall charge is +2. Overall charge is +2. Can you tell me what is the charge? Can you tell me what is the charge on the reactant side? Can you tell me what is the charge on reactant side? Yes, Irtaza and Roha, can you tell me what is the charge on reactant side? Oh, +7. Okay, Roha, not coming slow. Okay. Tala, can you confirm, please? She's saying that this is +7.
I think
Okay.
it's zero.
Shamir, can you confirm, please?
+7.
She plus, oh my God, okay. Hadia, Muzaffar, and Hafsa, can you confirm, please? She was saying right or wrong?
+7.
Is it 0?
0, oh my God, this is not 0. This is not 0. This is not 0. This is not 0. Let me tell you. This is -1. This is -1. This is -1. This is -1. Each hydrogen is +1. How many hydrogens you have? You will say, sir, 8. I will say 8 multiplied by +1 is +8. So +8 -1, you will say +7. Hey, this is baby question, man. This is +7. Why this is +7? Because +8 -1 +8. So why are you saying that +8 hydrogen is having +1 charge? You told me you have given like you are written the rules in that I have seen that hydrogen is +1. Yes, right now I'm also saying that hydrogen is +1. But as you can see how many hydrogens you have, you will say, sir, 8. I would ask, each hydrogen is +1. So how many hydrogens you have? 8 hydrogens you have. So obviously +1 multiplied by 8, that is going to give you +8. +8 and -1. So this is +7. In the product side, you had +2 charge. In the product side, you have +2 charge. This is not balanced. The charge is not balanced. The charge is not balanced. What you are supposed to do? What you are supposed to do? You are supposed to add electrons. You are supposed to add electrons. And you all guys know that electron is negatively charged particle. I am going to write 5 electrons over here. I am going to write 5 electrons over here. If you ask, sir, why? I will say, I just told you this was plus 7. This was plus 2. So what if I'm going to subtract 5 over here? It's going to give you plus 2. Yes, that's why I'm going to add 5 electrons. And you know that electron is a negatively charged particle. It means that I am going to write minus 5 in front of plus 7. Remember, okay? So right now this is balanced. Right now this is balanced. This is balanced. This is balanced. This is balanced. This is very easy. Are you having any difficulty? Do you have any question? Do you have any query? Feel free to ask. Yes, I'm waiting. I'm just giving you 30 seconds. If you have any query, let me know. Let me know. Yes. Yes or no? Yes or no? Maria is saying no, sir. Okay, Maria. Ahmed is saying no. Good. Hafsa. Hafsa, what do you think? Roha, what do you think? Samir, what do you think? Shamir, what do you think? Soha, Tala, Zoha. What do you think, man? Fast reply. Irtaza, yes. What do you think? Sir, please repeat charge balancing. Okay, Samir. Okay, no problem. Yes. Can anyone tell me, like, do you have any query? Yes, Roha. I have one question. Yes, please. Yes, Roha.
Sir, so I had the question that all of this will be added to the first Prittl line.
Basically we have to balance both equations, but right now I'm balancing the first equation, in which let's see what if someone is going to write 5 electrons over here. Someone is going to write 5 electrons over here. You know, already it had plus 2, so you are going to write minus 5. It's going to give you minus 3. Again, this is plus 7. Oh, the charge is not balanced. So I always suggest, just look at your equation and then consider the charge, and then just add electrons to that area in which you have more number. It means that this was plus 2 and this was plus 7. This is the larger number. I'm supposed to add electrons in that side. So this is the trick. This is the hint for you. This is the first equation, man. We would be balancing enormous amount of equations. I would be balancing more and more equations. So obviously you will be having, you can say you will be growing, inshallah. So after, like, you know, after practicing. Yes, Roha. Roha,
Yes, sir.
any question? Why I'm
No,
going
sir.
to add 5 electrons? Yes, okay.
Sir,
So basically, yes.
sir,
Shamir,
how did we get the -1 charge on oxygen?
beta, matlab, this is given. I'm not getting -1. Like, I don't know how this is. Like, this is the question basically. The examiner has given you MnO4 minus. This is the question. Examiner has given you. Okay, already given MnO4 minus. Okay.
Okay, sir.
And also MnO4 minus means that this is -1, right? So I have included this -1, and then I'm saying that if this is -1 and I have +8, means that each hydrogen is +1. So 8 hydrogen means that this is +8. So +8 minus 1 would be giving you +7. That's why I told you this is +7. That's why I told you this is +7. So this was +2. Then I'm supposed to write 5 electrons over here. Okay. So the first equation is over. I need to look at the second equation. Okay. I need to look at the second equation. So this is +3 and this is +2. There is no oxygen. There is no hydrogen. Just enjoy the party. There is no oxygen. There is no hydrogen. There is no any non-metal. Oh, this is only metal, and metal is already balanced. Iron is balanced. What you are supposed to do, just balance the charge. How? This is +3, this is +2. Can anyone tell me where I'm supposed to add electron? Left hand side or right hand side? Can anyone tell me? Yes. Left. Left means that if I'm going to add 1 electron, this would be 2 minus 1 is equal to +1. Oh, this is +3. Oh, this is +3. Yes. Maria, can you tell me, is this right or wrong? Yes. Maria is saying right. Maria is saying right. Tala, can you confirm, please? I'm supposed to add electron in the right-hand side or the left-hand side? Yes.
Right.
Right, exactly. Right-hand side. I told you this is the hint for you. You are supposed to add electrons in that side in which you have larger number. Larger number. In the reactant side, you have +2. This is +3. 3 is the larger number. I am adding electron over here. I'm adding electron over here. Yes, now again I am asking, do you have any query? Are you getting my point? Is that clear? Am I right? Yes, fast. I need your reply. Yes or no? Clear. Samir is saying clear. Soha, clear. Tala, Tala, Zoha, Irtal. Oh my God, oh my God, oh my God. Okay. Okay. Sayyid Muhammad Ahmad, are you getting my point? Yes? Sayyid Muhammad Ahmad, is that clear? Yes, clear. Okay. Hadia Muzaffar, any confusion? You're silent.
No, sir.
Hadia Muzaffar, okay, good. Hafsa, is that clear?
Yeah.
Oh, okay. So inshallah, we would be adding this equation in the next class. Okay, I would be adding this equation in the next class to have the final equation. Okay, this is easy, man. Do not worry about that. We would be practicing more and more and more square and more to power 3 and more infinity. So inshallah, so you will be having any difficulty. Okay. Thank you so much. Allah